But let's introduce our next speaker, Rami McCarthy. He's going to be speaking on learning from AWS customer security breaches. In light of the increasing cloud adoption, there have been a broad coverage on the compromise of customer environments in the cloud. Anything from the simplest open S3 buckets to deeper and much broader tactics that are used by attackers and researchers to compromise cloud environments. So this talk will focus on AWS and discuss over a dozen different public breaches. So let's welcome Rami McCarthy. Thank you.
Hi, folks. Let me get my slides up on screen. Awesome. So thank you for the introduction. Thanks everyone for tuning into this talk. And of course, thank you to the organizers of BSides Connecticut for putting this all together and for having me. This talk is learning from AWS customer security incidents, and we'll dive right in. First, before we get into the core content, some quick background on me. My name is Rami McCarthy, and I'm a former security consultant turned product security engineer. I'm AWS Certified in Security and hold the CCSK from the Cloud Security Alliance. I'm also the creator of sadcloud, which is an open source tool that lets you create configurably insecure AWS environments via Terraform, and I'm a contributor to ScoutSuite, which is an open source multi-cloud auditing tool. So let's talk AWS customer security breaches. Here's the plan for the next 28 or so minutes. First, we'll do a quick background on the cloud and AWS security to baseline everything. Then I'll introduce the main topic of AWS security incidents. I'll detour and tip my hat to some prior art on this topic, and then dive in and we'll go through the case studies that make up the meat of this talk. Finally, we'll pull out some trends from these cases, and I'll give recommendations to address what we find are the most common causes of real-world AWS breaches. So we need to start by establishing a working definition of the cloud. In essence, the cloud is just software and services that are running on the internet as opposed to locally on your computer or private network. That's the entire difference. In this talk, we'll be focusing on AWS, which is the largest public cloud provider by market share. About a third or more of all companies working in the cloud are running on AWS. So while we're looking at AWS here, and the cases we'll be looking at are all AWS specific, I do expect that many of the vulnerability trends and recommendations will be generalizable out to the broader cloud computing landscape. It's important to note this talk isn't intended to criticize AWS or compare AWS, its general security posture, to any other cloud provider. But as AWS is the dominant platform currently, it has the most public examples we can pull from. So before we get into examples, this is the shared responsibility model. And every talk about AWS should start with a discussion of the shared responsibility model. It comes directly from AWS, and its purpose is to break down in detail the balance of responsibility in securing your cloud account between you and AWS. As you can see, based on this visual, AWS is responsible for securing underlying resources and services, while you, the customer, need to own security for your workloads as well as configuration. That means that when you operate in AWS, you don't have to worry about, securing data centers. For services like S3, you don't need to be concerned directly with API security or the security of the underlying infrastructure. However, you're still responsible for configuration, and that includes authentication, authorization, firewalls, and a bunch of other things. The focus of this talk is going to fall entirely on the customer side of this model. So before we talk about specific cases, there are a few points I want to hammer on. First, the cases we discussed do not represent any breach or exploitation of AWS itself. I'm not going to be talking about any 0 days in AWS. Instead, they're instances of specific incidents with individual customers. And this is generally going to be due to their usage of AWS or how they configure the services they're using. And in some cases due to unrelated security posture of these companies at the time. I also want to make sure we enter this conversation with empathy. Incidents happen, and there's no such thing as perfect security. My goal is to keep this talk in line with this, principle of blameless postmortems. On this slide is a discussion of the concept pulled from Google's site reliability engineering book. Blameless postmortems focus on the root cause of an issue and try to remove any focus on the, people involved. This is based on the idea that incidents are not the result of individuals, but are broader failures of process, technology, etc. And these incidents should be owned by the whole organization and looked at holistically. With that said, we're going to talk about some public AWS security incidents, and I appreciate those of these organizations that have released postmortems publicly. That sort of transparency is super valuable to us all. And so I really want to highlight that as a positive, as opposed to criticize any of the organizations who, have unfortunately suffered a breach. First, I want to touch on the most common and most publicized incidents in AWS as a broad class, which is the accidental exposure of sensitive data via misconfigured services, which allow unintentional public access. This is most broadly discussed through the numerous, broadly covered examples of S3 buckets being open and breached, but can also include things like misconfigured Elasticsearch clusters. I'm not going to explore these in depth in this talk just because I think it's been covered at length. The links on the slides there do give you some kind of compilations of these sorts of interests if that's something that piques your interest and you're looking to learn more. I'll also share these slides at the end of the talk, so all these links will be accessible. The other type of incident I want to highlight without going into specific cases really is ransomware. Ransomware is a type of malware that steals data, encrypts it, or both, and then threatens to release or retain that data unless the attacker is paid a ransom. Ransomware is most commonly discussed in traditional environments. Recently, it was in the news due to hitting a lot of hospital networks. But ransomware can also target cloud environments and is growing more common there. There's no good single case to discuss because this is a more recent trend, but I want to give the high level. Ransomware can target either AWS services or user-managed resources running in AWS. So, your Redshift or maybe RDS is an AWS service that could be targeted. Or if you're running MySQL server on an EC2 instance in the cloud, that also could be a target. Generally, the root cause here I've seen is internet exposure combined with a weak password. And then, of course, a brute force attack against that password grants the attacker access and they can start, ransoming the database. I've linked to some forum threads with users reporting this in their environment just to show you that this is an active threat. And I've also heard from some peers who've seen this happen at their companies, but those incidents aren't public yet. It's definitely something to be aware of on the horizon. But again, there just aren't some good cases to point to, so I call it out here. As promised, I want to provide some pointers to other discussions on this topic and, tip my hat to previous talks and perspectives on AWS customer security incidents. First off, Spencer gave a forward-looking talk at DEF CON's Cloud Village this year, where he discusses kind of what the future of ransomware in the cloud will look like, what the mechanisms for ransom in the cloud are. If my earlier mention of ransomware, if this is a topic that interests you, Spencer's talk is a good place to start. There were also 2 talks on cloud security incidents at the SANS Cloud Security Summit this year, first from Dave Shackelford and then from FireEye Mandiant. And James Condon gave this talk at the inaugural Forward CloudSec conference this year, where he highlighted some cloud threat actors. Finally, F5 included a bunch of instances part of their Is the Cloud Safe series. And again, all of the incidents and all of these talks are going to be present in this presentation, but they're a place to go to learn more. Now, it's time to move on to sort of the main event here, which is going to be a survey of AWS customer security incidents. For each one, I'll give you a pointer for where to learn more, but I'm going to cover just the initial vector of compromise, any escalation or pivoting mechanisms that were used, and the resultant impact as a result of the breach or incident. So the first one we have to talk about is probably the example most people will likely be familiar with, which is last year's Capital One breach. In August of last year, a former AWS employee exploited a misconfigured instance of Mod Security, which is an open source web application firewall. And this was misconfigured in a way that let them perform an SSRF attack on the metadata service. And to break that down a little more, a server-side request forgery attack is where the attacker manages to get a victim server to make responses on their behalf and return the response. They can control the victim server to that extent. In AWS, this was particularly high impact, as an SSRF vulnerability could retrieve the credentials that were connected to an instance and then gave the attacker AWS permissions. In this case, the role stored in the metadata service was over permissions. This is a web application firewall that had some AWS permissions, but for whatever reason in this environment, those permissions included undue access to sensitive data from Capital One's S3 buckets. The data included over 100 million credit card applications that were stored in S3 with all sorts of, sensitive data. Thankfully, the attacker was arrested and had never spread the data, so this didn't make it into broader distribution, but it's still a really notable incident and got a ton of press coverage at the time. This next case is pretty much a worst case scenario and is often bandied about as a horror story effectively. CodeSpaces was a cloud-based code hosting collaboration company, and they were breached all the way back in 2014. Attackers somehow gained access to AWS console credentials for CodeSpaces through an unknown vector. A lot of people suspect phishing, but we don't know that for sure. They also simultaneously were performing a denial of service attack that was, a distraction for this breach. The attackers created backup logins, additional accounts and keys, and when CodeSpaces attempted to regain control of the account, the attackers began wiping data, S3 buckets, EC2 instances, snapshots. In the end, CodeSpaces was actually completely unable to recover and went out of business as a result, which is why this is such a notable incident. It's shown that the consequences of a breach can, ruin your company effectively. Next up is the DNC hack by the GRU during the 2016 election. I pulled these details actually from the DNC's lawsuit, which is linked at the bottom there. The initial vector here wasn't disclosed, but the result was a compromise of test instances of Tableau and Vertica, which were being used for some data analysis. The attackers exfiltrated the data by copying EC2 snapshots to accounts they controlled. And they walked away with not sensitive data, but actually the queries themselves, which were considered sensitive by the DNC as they gave away some strategic, signals. And this was only with the breach of a test cluster. So again, something to think about there. A lot of people secure their test and production environments differently. And this goes to show that you need to be really conscious of where your sensitive data lies, what you care about, and how you protect it. The DataDog case is, in my opinion, a much more standard example of an AWS security breach. DataDog had an incident in 2016 where the AWS access key and an SSH private key used for their CI/CD pipeline, think something like Jenkins, were leaked. However, they don't know exactly how these were leaked, or at least it wasn't disclosed, but generally this is via accidental commits to public Git repositories, which we'll see and discuss in some of the other cases. The attacker in this case was able to use the leaked keys to access a small subset of EC2 instances and S3 buckets in DataDog's account, and then tried to use that access to pivot with customer credentials, because DataDog is SaaS software. That was unsuccessful, thankfully, and the attack took place over just like 7 or so hours and was identified and quarantined shortly after. Uber had a 2016 AWS incident, which wasn't disclosed until 2017. Here, again, we're seeing AWS credentials accessed via a Git repository. In this case, it was actually a private GitHub repo, but it was lacking multi-factor authentication at the time, which was a contributing factor. Attackers were able to access personally identifiable information on 57 million users, as well as names and driver license numbers for 600,000 drivers. The case had an interesting twist, actually, and I recommend you kind of read up on this because Uber paid the attackers $100,000 as a bug bounty to to resolve the breach, and that was paid through HackerOne. But the incident continues to make waves. Uber's former chief security officer was just charged back in August, I believe, by the Department of Justice for allegedly covering up this breach. And there's definitely a lot of interesting discussions around that and important to think about as a security practitioner. OneLogin's 2017 incident is another case of an unknown origin, and somehow AWS keys were compromised. In this case, the attackers created EC2 instances within the environment and used those to perform further reconnaissance. They moved on to access database tables that had sensitive data, but in fact, some of that data was encrypted. Unfortunately, despite the use of encryption here, OneLogin wasn't able to confirm whether or not the attackers had also accessed the encryption keys. And as a result, they had to treat the data as compromised as a whole. Again, as we're talking through these incidents, if you're administering an AWS environment, I definitely, in the back of your mind, think about how and where you would be detecting these incidents, what you would do to resolve them, and I'll go into some recommendations at the end. Politifact had a very different type of incident in 2017, and there's minimal information on it because it was fairly small, but effectively a Twitter user researcher noticed CoinHive running on Politifact's website. CoinHive is a Monero crypto mining script, so basically it uses some or all of the browser resources of a person visiting the site to try and mine cryptocurrency. Politifact's executive director did attribute this to a misconfigured cloud computing server, but there's no further information as far as I'm aware. But the LA Times had a 2018 incident that was very similar with CoinHive crypto mining. In this case, it was directly attributed to an S3 bucket with global write access. The attackers were able to add that crypto mining code directly to the S3 bucket because of that misconfiguration. And so it's likely that Politifact had similar causes. Tesla in 2018 also had an incident. In their case, a misconfigured Kubernetes console lacked password protection, which attackers used to spin up resources and mine cryptocurrency. And so this was similar to crypto mining attacks. In this case, the attackers, instead of using kind of browser resources, actually spun up inside Tesla's AWS account resources they used to mine cryptocurrency. Imperva also disclosed a breach in 2018, and in their case, they had externally exposed a compute instance, and it was globally accessible. And they said it contained an AWS API key. And it's not clear whether this is, a key stored directly in the instance, or if this is another incident with metadata access, potentially like Capital One. That access that the attackers gained was used to steal a database snapshot that had been created during testing and kind of forgotten about. So again, think about a lot of things that went wrong here, and Imperva's blog talks about their lessons learned as well, as do many of these postmortems, which makes them so valuable. In a fairly novel example, a recent plea agreement highlighted a 2018 Cisco security incident, which in that case, a former employee who hadn't been working for them for about 5 months or so deleted a bunch of EC2 instances in their account. This is interesting because there's some speculation that this was just a complete accident, that the engineer was trying to, destroy some infrastructure in either their current employer or personal, using infrastructure as code, something like Terraform or CloudFormation. This hasn't been confirmed that this was an accident and that was the case, but it does show that malice is not always a component of an incident. JW Players, another victim of cryptojacking, this time in 2019. In their case, WeaveScope was publicly exposed, and that's a container monitoring tool that has RCE by design. The tool has code execution functionality, so the attackers could just directly use this public tool to spin up resources and mine cryptocurrency. Malindo Air is another new vector we haven't seen in these previous cases. Former employees for a contractor of theirs used their authorized access and expanded it to pull down 35 million customer records they were not approved to access. And Twilio, like the LA Times, this time in 2020, had an S3 bucket with global write access. In this case, it was opportunistically exploited, so they weren't specifically targeted here. And an SDK they provide was backdoored with MageCart, which tries to do credit card skimming generally. In this case, the incident was quickly identified and resolved, and there was really no impact because the SDK that was backdoored had nothing to do with credit card processing. So, quick sidebar on MageCart and S3 Global Right. I'm going through these cases. This is non-scientific and is going to be much more qualitative than quantitative throughout this talk. But I do want to point out that there are far more instances of S3 Global Right being an issue for organizations than I'm talking about here. RiskIQ in 2019 discovered that, MageCart was hitting over 17,000 domains or organizations via S3 bucket global right. So this is a well-known and broad issue, even though I'm only going to call out a couple specific examples. All right, just a few more here. Expel is a SOC as a service provider. So they provide managed security services, and they've blogged about a couple of the instances they respond to. And these blog posts are really excellent, and I'd recommend tracking them down if you're interested. In the first of these, a root IAM user access key was somehow compromised, and attackers generated SSH keys for a bunch of EC2 instances and then used those for cryptojacking. Again, we see, using computing resources to mine cryptocurrency is one of the common results of these breaches, as it's an easy way for attackers to turn their access into cash. In the second of these blogs, 8 IAM access keys were compromised. Those keys were used to backdoor security groups to allow the attackers internet access into the environment to EC2 instances. The final impact we don't actually know because once attackers had command line access to EC2 instances, there was not sufficient monitoring or visibility in place really to determine what they did with that access. So again, a lesson there about monitoring and where you need it in a cloud environment. The Team TNT Worm is an escalation to these cryptojacking attacks because it automatically scans and exploits misconfigured Docker and Kubernetes platforms and has recently added features, recently as in this year, to steal AWS credentials from the directory in which they're stored in plain text. So far, it's only been observed to do cryptojacking for Monero and to pass those credentials back to the control server. So it hasn't actually abused these credentials yet, but that's only likely to change as the this and similar worms mature. Crypto mining AMI, this is another vector, again, for cryptocurrency mining, abusing cloud incidents. In this case, a Windows 2008 server AMI, Amazon Machine Image, had been around for 5 years, was identified that contained a Monero miner. So AMIs are pretty much templates for spinning up a virtual machine in EC2, and you can create them yourself, you can buy them, or you can retrieve them from the community marketplace. And so this was one that was publicly available on AWS in the community marketplace if you searched Windows 2008 at the time. And once you started using it, it would actually, be mining Monero in your account. Finally, the Mandiant talk I referenced earlier gave a really interesting insider threat scenario. Again, go to that source if you want to see the full details. In this case, a fired employee, shortly after their final day, used their credentials to reach a CI/CD server, created new users, stole additional credentials, and eventually deleted production databases. Obviously, the recovery effort here is going to be huge. So that's, a risk to be really concerned about. Having surveyed that wide range of cases, we're going to kind of blow through some trends. This is not scientific. This is qualitative more than quantitative. These numbers are not representative, just a bunch of caveats there. But quickly looking at it, before looking at our cases, I wanted to point to MITRE ATT&CK AWS Matrix. MITRE is a knowledge base of tactics, techniques, and procedures. They released metrics for cloud providers fairly recently, but they're planning to merge these into a single matrix soon. The most important category for us is initial access, where you can see exploiting public-facing applications, trusted relationships, and valid accounts are the three main techniques. And now looking at our data, we saw single instances of an unknown initial access vector as well as malicious AMI. We saw a couple instances likely tied to metadata access, 3 each of abuse of valid credentials, vulnerabilities in apps, and S3 global write, and valid credential theft. And again, I just want to highlight there are far more instances due to S3 global write than our case is indicated, and that could be true of other classes of vulnerability. So in the last few minutes here, I'm going to do a speed run through the best controls, the recommended controls for the common vectors we've talked about here. So first up, metadata access. Metadata access generally requires some sort of vulnerability to be exploited first. So if you have a secure software development lifecycle, if you're doing pen testing, stack analysis, etc., a general code hygiene will prevent those initial vulnerabilities from being exploitable. And the metadata service, IMDS is the metadata service, has a second version that uses a put request to create a session token that you then need to use that token to get the metadata. And this will defend against SSRF getting you directly metadata access. S3 global write has been a big problem. And so AWS released Access Analyzer for S3 that will directly tell you whether any S3 buckets are configured to allow internet access or access to accounts outside your organization. So that's a huge win there. And malicious AMI is similarly straightforward. Make sure you're using trusted sources for your machine images. The convenience and cost of the community marketplace is appealing. But, as that case showed, and especially the fact that the malicious image lasted in the community marketplace for 5 years, you just shouldn't be using the community marketplace for AMIs for production. Application vulnerabilities aren't super cloud specific generally. Asset inventory and patch management, you need to know what apps you have, and you need to make sure that you're at least defending against known vulnerabilities in those applications through patch management. Cloud specific is external exposure. So most services and resources in AWS and in all cloud environments can be publicly exposed, but shouldn't be. So keep that in mind. Valid credential abuse is a big one. So this is where former employees or maybe third parties are abusing their access. So step one, offboarding. Make sure you have an offboarding plan in place and you activate it as soon as someone leaves your organization so there's no access lingering there. Watch out for third-party risk. Follow the principle of least privilege and minimize access in your environment in the first place. And then login monitoring is important. And these are some of the heuristics for login activity that are common to use. Check what times of day, location, activity, and look for deviations. And then there is valid credential theft. This has been maybe the most common reason is someone somehow gains access to valid credentials and uses them in your environment. Follow IAM best practices with MFA, key rotation, and avoiding static credentials where possible. And again, this is a huge topic I'm just glancing over. The principle of least privilege helps here. There's a really good tool that was released this year called Cloudsplaining. Cloudsplaining will actually break down across your environment in IAM, whether there's privilege escalation or maybe over privileging. And so you can use this open source tool to audit IAM in your account. And again, these slides will be available so you can kind of go back and grab these links if you want to know more. Awesome. So that was a bit of a speed run. Thank you all for sitting through it with me. I'm paying the puppy tax with my 8-week-old puppy. So there's that. Feel free to track me down in Discord or on Twitter if you have any questions. But otherwise, these slides will be up on Speaker Deck, and I'll drop a link in the Discord channel for this talk where you have access to those. So thanks, everyone.